All right. Welcome to the February 16, 2023 edition of the Long Coffee Break. Hopefully you've had a chance to grab a warm drink and you're ready to join us as we discuss the expectations, mysteries, follies, and opportunities that surround the topic of equipment startup. Joining me today live and in person is Rick Williams from the Colorado branch of Daikin Applied. Rick is the lead technician for Daikin. We sales engineers at Long lean on Rick frequently, not only for startup, but for troubleshooting and being our eyes and ears in the field. He is a trusted partner of ours, and I'm grateful to have him with us today. Before I turn the microphone over to Rick, let's review some of the initial steps of the equipment startup process. First, the specification requirement for factory authorized startup is usually a pretty short blurb, but its importance is huge. Without proper startup, the equipment, whether it be a rooftop unit or chiller, etc., may struggle to meet the owner's project objectives right out of the gate. And the intent of the specification often goes far beyond just getting fans spinning in the right direction or ensuring that a component is not dead on arrival. This is the best time to make sure that the equipment is operating according to the specified control sequence and tune the machine with the cooperation of the controls contractor and the tab contractor. And then fast forward to the startup result, we want properly operating piece of equipment, and the startup date is often associated with forms that are used to begin the clock on the warranty date. But in between the requirement and warranty period, there are some important activities that need to take place, and that's where Rick is going to talk about some of these activities and some of the issues to avoid when we get so that we can get the most out of the technician's time on site. Thanks, Rick. If you could let us just kind of lead us through some of the things to avoid, please.
So some of the key components to a successful startup are ensuring that the installation is in fact complete, that the unit's on the curb, that the ductwork's connected, that the controls are as close to ready as possible, that the necessary controls components of the machine, like discharge air temp sensors, are landed in the proper location per the installation manual. Gas pipe is connected and operable. Basically the installation needs to be completed entirely so that we can start the unit and commission it with the controls contractor so that you can avoid commissioning delays.
Yeah.
That's the biggest thing that we run into is ductwork not installed, Mighty Blue all over the room, no controls, no power. We've had instances where we come up and there's no line voltage electrical ran to the disconnect, or the conduit's there, but there's not even wire in it. It's impossible to start a piece of equipment in that condition. There are some very minor things we can do, like tightening onboard electrical and remove some shipping components and shipping bolts, but that's it. Some of the other stuff that is usually necessary is the building needs to be relatively complete, so that when you are starting the equipment, you have a facility to service for the equipment to serve.
Mm-hmm.
If the building's not ready, the units aren't really ready. It's not the most ideal condition to use a very expensive rooftop unit as a temporary heating or cooling source, although we know it sometimes is necessary and happens. It's not the most ideal. You also don't want to not maintain that piece of equipment while it is started in a temporary application. You want to be able to change those filters on a regular basis and make sure that you're protecting that piece of equipment. So that falls into the job site conditions not quite being there.
Yeah.
Specifically to PDUs, if we don't have windows, doors, water in the pool, certain components to the facility, the adjacent space isn't isolatable from the space that the pool unit serves, it's hard to balance that unit and set that unit up appropriately.
Yeah.
So then we have a lot of return trips, and that creates more delays for everybody. So
Yeah. I think at the end of the day, right, we're trying to start up the equipment in what's supposed to be the final state of the building, which we're, in today's day and age in construction with equipment delays and doors and windows, the whole construction industry is a little bit different spot than we're used to being in for decades previous. And that can create pressures, but if we're going to get the most out of startup, we want to see that building in its final state.
Right, as ready as possible, as close to turnover as possible.
Right.
Your startup technicians honestly should be the next to last people on the job. It should be startup, then controls and commissioning agent. and then the owner has the building. That's when the startup should be occurring, is after the equipment's installed and everything else is relatively close to completion.
Yeah, exactly.
Then that's where you're going to get the best protection for the equipment, the best efficiency out of the time necessary to do the startup. We're going to be able to work with the temperature controls contractor to iron out any issues with control sequence and stuff like that before commissioning occurs.
Yeah, beautiful.
So
Let's go to what I'll call the startup folly reel here, and this is a beauty. Walk us through. These are photos that you've taken, so walk us through these.
So these are some photos that I've taken and my technicians have taken in the field. The first one here you see is, we're here to start up the equipment and it's hanging from a crane. Now there are other multiple pieces of equipment on this job site, and there were some that were in a more ready state than this, but this is an example. We've come to startups in quite a bit of instances where the equipment's not even set, it's not even there, but we're there for startup. So and the next picture is one that shows the ductwork not complete. The transition's not installed. It's sitting there. It's laying there on the job. It's ready to go, but it's not there. So it's not the most ideal condition to try to start this piece of equipment.
Exactly.
This example here is of line voltage and control wiring conduit penetrating through the ground with nothing in it. But of course, without power, we can't run the machine. We have another here with gas line not connected, so we can't verify gas operation or pressure. It's literally hanging there from a string and under a pressure test still with a pipe cap on it. Of course, line voltage not connected to a disconnect. This is an example of the controls not quite complete on the left there. And in that instance on the controls, if the controls are in the unit, if the temperature controls contractor has it in the unit and it's coiled up and landed and labeled, we have absolutely no issue with landing those controls and assisting with that to move the project alone. But if it's not there at all, it's kind of hard to commission the unit or even start it for that matter. The middle picture you see is an example of following the installation instructions. That is the discharge air temp sensor. The discharge air temp sensor on our Rebel units, per the IOM, is supposed to be installed between 5 and 10 feet downstream of the unit before any additional appliances, VAVs, fan powered boxes, or anything like that. When it's in this particular instance, that's the penetration for the water lines for the hydronic heating coil. It is literally mounted in the curb right under the unit. So it's not in the proper location. That'll impact the ability of these units to run and meet the sequence. It'll short cycle off and on heat and not allow it to function properly. So that'll create, in this circumstance, it creates a commissioning log event where the commissioning agent will say this thing's not performing the way it's supposed to. And this is something that we tend to find, is that these are not located in the right spot. The other picture here to the right is, in this particular circumstance, the temperature controls contractor ran a control wire through the fan. And somebody, before we arrived on site to perform the startup, had energized the unit to get the fan running in a temporary capacity and didn't verify that prior to doing it. And a control wire was in the fan when it started. So of course we had to repair that, which created a delay. And it caused some damage to the automation system, which they had to wait on parts and repair, which also added to delay times for turnover for the owner. So it's just really a matter of look at the equipment, look at the state, and look and think, would you want this running? With the investment that's here, I understand time is of the utmost importance in getting these jobs turned over, but we also got to think about what's best for the equipment, and what's ultimately best for the owner at the end. And doing the right thing and waiting and having that patience to start it when it's ready is the best option.
So we've talked about this, right? What are if I've got a contractor and I've got a mechanical contractor and he's under the pressure of the general contractor to get somebody out here on this site today to get this started up because that's what the construction schedule says. What can we do to help out our customers to make them realize what could and could not be a good idea to get the startup going sooner?
So I think, like you said, we've had discussions about this, and all of us have, and I think the best option would be, let's plan on having someone from Daikin, myself or one of our technicians, come out and walk the job initially with the job site superintendent, the sheet metal foreman, whoever is the representative for the mechanical contractor on that site, and just walk it and verify the pre-startup checklist and look at the job site conditions and just verify that it is in fact ready for startup before we commit to a hard schedule to come out and start multiple pieces of equipment and waste time ultimately. If we just get ahead of it and say, hey, let's take a look. And then at the same time, if we do that, those individuals that are running the jobs, the superintendents and the foreman, would have the opportunity to learn what is necessary and where at in the job, what step they're at in the job as far as readiness for startup.
Right.
So, and we're happy to help with that and work with individuals to help them learn, to avoid these conditions where we show up and the unit's hanging from a crane.
Yeah.
Because that job is just not ready.
Yeah.
There's no way it can be. If there's no power or gas, there's so much of the job we can't do.
Right.
So I think it'd be a good learning tool for us to give that time and come to the job site and actually survey it and verify readiness.
Yeah, absolutely. Absolutely.
So,
What is like some of the pitfalls of starting up a piece of equipment before the equipment doesn't care if I have doors and windows, does it? Like, why would you care?
right. So the reason I care is because you're going to want that unit to run to maintain duct static. If there's nothing there to create resistance against that duct, like windows and doors, then we're not tuning it to the duct static that it's necessary. The other thing is environmental issues. Some of the components of these are very susceptible to, if like your filters, for instance, if you're running this thing in a condition where the job site's extremely dirty and there's debris and crap in the building, that's all getting into your filters. Well, if we're going through and trying to commission CFM to a tight tolerance or something like that, or we're trying to maintain pressures to a tight tolerance, those filters affect that pressure. So those would need to be changed. That's more time because now we have to wait for the filters to get on site, and it creates a delay. It can cause some premature faults and alarms in the machine in an instance where, once again, if the filters are extremely plugged because there's drywall dust now, we could get intermittent high limit trips on a furnace. If we're trying to run that thing in a temporary capacity to like heat a gym so they can put the floor in, it's kind of hard to keep it heating if it can't move air.
Right.
So those conditions of starting it early create maintenance concerns with the unit that don't always get addressed when we're doing a temporary startup.
Absolutely.
So that, just having the right job site conditions matter. You want to start the unit and commission it in its final operating state or as close to the final operating state as possible so that you have, the efficiency of turnover and you don't have as many problems after the fact.
Yep.
So, because the other thing we don't want to have and we want to avoid is for the end user, the owner, to have a bunch of warranty concerns. And, now they have lost faith or trust in the equipment because it fails prematurely.
Exactly.
And a lot of that is from starting it in a bad condition.
Yeah.
That could be avoided. So.
Absolutely. Well, Rick, thanks for joining me today. Please join us next week when Lindsay will co-host with Specified Controls to discuss gas detection systems. Have a wonderful and productive day, you all. Thanks. Bye.